I ran nginx in production for 2 years. One afternoon last spring I deleted every nginx config and moved the whole stack to Caddy. Caddy has renewed my TLS certificates on its own ever since. I have not opened a third boot once. By the end of this video you'll have a 5-line config that does the same for your site. Speed had nothing to do with it. 5 lines of Caddy did the job that took nginx about 30. The short config got my attention. 3 hour things keep me here, and I used to pay for all 3 with nginx plugins and cron jobs. I show you each one. Run any site on HTTPS and you babysit 3 things: the web server, the certificate, and the renewal job that breaks at 3 AM once you've forgotten it exists. And Caddy puts all 3 in one binary. It runs the same way on your laptop, and I'll get to that. This is a reverse proxy in front of my app on HTTPS and nginx first. This before third boot, the renewal timer, and the load hook that makes nginx pick up a fresh cert. Same job on Caddy. This is the who file. Write your domain, Caddy fetch the certificate, serves HTTP2 and HTTP3, redirects port 18 to 433 and renews the server before it expires. You wrote? None of that. This is the one that sold me. nginx never do it for me. Caddy runs the ACME handshake itself. It talks to Let's Encrypt or ZeroSSL, proves its own the domain, installs the cert and loads it into memory with zero downtime. No reload, no restart. Caddy keeps the renewal schedule in the background and you never touch it. On nginx I wrote a reload hook so the server would notice a fresh certificate. On Caddy that hook is gone because the job is gone. The 3 AM expiry that used to wake me up, I have not seen one since I switched. Here's how I ship it for clients. Caddy sits in the same Docker Compose stack as the app. One named volume holds the certificates, so they survive a rebuild. I deploy and the site comes up on HTTPS before I finish reading the logs. The whole TLS story lives in that Caddy.volume. I back it up with the rest of the project. No etc Let's Encrypt on the host. No sort state scattered outside the container. Last month one of my clients had to leave their VPS provider. He doubled the renewal price and gave them 2 weeks. Their app ran behind Caddy in the stack. Moving it took me one command. I moved the project and the Caddy data volume to the new box and start Caddy. The certificate was already in the volume, still valid, still mid-cycle, so Caddy served it on the first request. It never called Let's Encrypt. That last part matters more than it sounds. On the old server boot, set up every fresh server meant a brand new certificate. And Let's Encrypt caps how many identical certificates you can pull in a week. Rebuild or migrate a couple of times in those 2 weeks and you trip the limit. Then you see they're serving a browser warning to the client's customers while the clock runs down. There is a second trap that setup walks you into. A move means you repoint DNS at the new box. With third boot, the new box has no certificate until it answers an ACME challenge. And that challenge needs DNS already pointing at it. So either flip DNS and let the site answer on plain HTTP for a few minutes without the cert issues, or make the whole thing and hope that timing lines up, but the volume skips it. The certificate is already there, so the second DNS points at the new box, the site comes up green, no HTTP gap, no safe sign placeholder. I did the whole move in the middle of a Tuesday. The client's customers keep placing orders the entire time. Nobody emailed me about the warning. The client learned the server changed when I told them on our next call. Second thing, I use this one every day. You know the local HTTPS pain, self-signed certs, browser warnings, I have broken in key cert setup. You read it on every machine. Caddy fixes it with one word. TLS internal tells Caddy to spin up its own certificate authority and sign a cert for you local name. Run Caddy trust once and your system trusts that CA. Your dev site loads on real HTTPS, green padlock, no warnings. The same OAuth redirects and secure cookies you run in production now work on your machine. I test the exact TLS behavior ship before I ship it. Reverse proxy is not a toy. Give it more than one backend and it spreads traffic across them at a health endpoint and stops sending requests to that node on its own. Round robin across 3 nodes. Every 10 seconds Caddy pings health Z, a node that fails drop out of rotation and rejoins when it recovers. On nginx that meant an upstream block plus the commercial module for active checks. On Caddy it's 4 lines in the standard binary. And the boring stuff you'd reach for a module for on nginx, file store with directory browsing, gzip and zstd compression, basic auth with bcrypt hash, all directives, no apt install, no recompile. First thing in this one made me read the source. Underneath, Caddy runs on JSON and exposes live admin API and localhost port 2019. Caddy reload validates the new config, starts the new listeners before it kills the old ones, and rolls back on its own if the config breaks. Active connections never drop. Add script config change in CI, push them over the API, and never bans the process. Compare that to editing a file and praying through restart. Two things matter when you ship this for real clients. First, Wildcards, a multi-tenant app, needs one sort across every subdomain that takes a Genius challenge, which takes a Genius provider plugin. You compile it in with Caddy, Caddy's build tool. One wildcard sort covers every tenant subdomain, renewed our Genius on its own. Second, and this is why I respect the project as a builder. Caddy is written in Go, plugins are Go models. You import them and they compile into one static binary. No plugin directory to manage on the server, no version drift between the model and the core, no shared library hell. A plugin is a dependency and the build hands you one artifact you can HTTP anywhere. That's the extensibility model I want from every tool I run. And free fire pushbacks I hear a lot. 1. nginx is faster. For rough static file throw path at huge scale, don't nginx, still wins benchmarks. For reverse proxy in front of an app server, you won't fill the gap. I don't. And think about where the time goes. Your request spends milliseconds in the app and the database, the proxy in front adds microseconds. Tuning the proxy to save a microsecond while a database query runs for 10 milliseconds is optimizing the part that was never slow. 2. Automatic HTTPS need ports 18 and 433 reachable for the Acme challenge. Behind a network that blocks them, you switch to the DNS challenge, still one config block, still automatic, and the DNS challenge needs no open ports at all. That means a real public certificate on a box the internet can't even reach. An internal dashboard behind your VPN, a private admin tool, a service only your team hits, can approve the domain through your DNS provider, and the service stays invisible from the outside. 3. Some directives need a custom build. They do. You run one Caddy build or pull pre-built image once, then you forget it, and you don't even need the build tool on your machine. Caddy's download page lists every plugin with a checkbox, tick the ones you want, and it builds the binary on their site and hands you the file. No go install it, no command to run. You download one executable with your plugins already baked in. Caddy is on the 2.11 line as of this recording. Written in Go, single static binary, Apache 2, over 70,000 stars on GitHub, one node from a builder, pin a recent tag and update it. The 2.11 line shipped real security fixes this year, CVS and all, the same as any server you run in production. I run AI systems for clients and Caddy scenes in front of most of them. It fits how I work. Less config, more time on the parts that pay, still pasting your boot cron jobs, copy the 5-line Caddy file below and delete problem for your stack tonight.